All right, if you're just tuning in, just put some various problems up on the board that these are just random. There could be problems like these. Maybe these could be the exact problems that you have, or what you see written on the right-hand side, okay? But not everything is written up there. In other words, some of these are up here, okay? Some of them are missing, but we did go over them in class. We have, as you can see, some alkanes. There could be alkynes, alkenes. There's aromatics on there, and then there's also ring structures, and perhaps isomers. Maybe you may have some of those on there too. So with that, okay, would you like to just go in a random order, or how would you like to approach this? Okay. Just like we've done every other time, the first thing you're going to want to do is find what? Okay. Okay. So then that is correct. So since it's 5, is there anything significant about that compound? Okay. It's an alkene, so we've associated that.
Something at the beginning of cis.
Yeah, it is something. That's why it's up there. So which carbon is that double bond located after?
2.
Okay. So is it after this second carbon or after this second carbon? This one. Okay. So anything else with that? So do we have just 2 pentene?
2, 3
Cis 2
methyl.
pentane.
Cis 3 methyl 2 pentene.
Nope.
Trans.
Nope. We said the cis isomer, that's incorrect. We said the trans isomer, that's incorrect. So if we wanted to make this per se this instead, I bet maybe that makes it a little more clear. Now you've got a trans isomer.
You just told us it was.
I know I did. But we also changed something. Right. Exactly what your classmate said. Okay? So now, what we have here is after our second carbon, okay, do we have anything else branching off of this chain here? There's a methyl group on which carbon? Right. So therefore, which one of these has to have something written after it? 2 or 3?
3.
Okay? So on our third carbon, we have a methyl group. So we've accounted for this. Then we just need to account for that. Remember, if there's nothing written after a number, it's telling you where a bond is located or its organic family, whether it's a ketone, whether it's an alcohol, or a double bond in this case.
So trans and cis only work on side.
That's correct. Because you don't have hydrogens bonding around that double bond. That's why if we take this off, you have your hydrogens pointing in opposite direction. That makes it a trans compound. if their hydrogens are pointing in the same direction, then it's a cis compound. But this has neither, so therefore it can't be a trans or a cis isomer. Okay. So we can get rid of,
Wait, so the top one, if you erase those two carbons coming off the bottom, it'd be a trans or a cis?
that's correct. All right, so we'll go ahead and erase this, so try to eliminate some of the confusion here. Okay. Of these two, which one is more simple or simpler? Okay, so this is called what then? Okay, or hydroxybenzene. That's the scientific name. Phenol is the common name. Okay, you can put either one, hydroxybenzene or phenol. But it's when you're conversing with your classmates is when you're going to want to be careful. You're probably better off writing phenol because it's just simpler. All right. So we can get rid of this one now. Okay. So making our progression, what do we have here?
1,4 dichloral 2-methyl cyclohexane.
Okay. So let's just put some of this together. We heard this. Okay. So we haven't accounted for anything, just our ring structure. So we have some derivatives, whether they're halogen or alkyl derivatives branching off of this. So we want to give the lowest possible numbers and in alphabetical order. So alphabetically speaking, which one is first?
Chloral.
Okay, so the chloral, so this is C, this one is C, and this one is, okay. So when we're talking about alphabetically speaking, it has to be either this one or this one.
Probably C.
And then after that, we want the lowest possible numbers. So if we take this one, okay, chances are we know that we would not go counterclockwise because then you're going all the way from 1 to 4 to 5. Those are some pretty big numbers. Okay? So what happens if we pick this one and go clockwise? Well, then we end up at 1, 2, and 4. Okay? Or if we pick this one and decide to go this direction, we're in the same boat. We've got 1, 4, and 5. That's too big. If we pick this one and go counterclockwise, then we're sitting at 1, 3, and 4. Okay? So 1, 3, and 4. So which one would make the most sense? This one. So eliminate that, and eliminate that. Once we do that, we've got 1, comma what? Okay? Dichloral. And then what's left? 2 dash and run out of room. Methyl cyclohexane. Okay? Sure, I can move. Okay, so I believe we can erase this one. this. Okay. So, purple or brown, light brown, red, or, okay? So, what might the first thing we would possibly do here? Okay, so our longest continuous chain is what do we think? I think you said it. It is. And it's all single bonded, so we can go ahead and write heptane. Okay. So then what do we have branching off of our heptane? We have two methyl groups. So when we say X marks the spot, that's where we've got derivatives that are branching off of our parent chain. We have, as you had alluded to, I almost said alluded to is we've got a methyl group here, we have a methyl group up here, and what do we have here? We have an ethyl. Okay. So the next thing we need to do is of those three derivatives, here, here, and here, who is coming first?
Ethyl.
Because the dye doesn't count.
E becomes before M.
Okay. But doesn't D come before E?
No, you don't count the D.
Okay.
Disregard it.
When it comes to prefixes, we disregard the letter D for DI and move on to letter E for ethyl, which looks like it was what, 4? Okay. And one of the things that could happen is, what about if this was moved over 1? Maybe we would have that, but more than likely not, because those numbers are still too big. So we've got 4 dash ethyl. So we've accounted for this derivative. We've got 2 alkyl derivatives left.
2, 4.
Okay. And, whoops, not comma. No, I wouldn't count it wrong. That's still not right.
I'm writing your parent.
2, 4, yes. And run out of space again. Okay, I understand you have derivatives on the 4th carbon, and right there they are. There's 2 of them. Okay. Could this change the complexity of this? Not only could, it certainly would. Why is that? We no longer have 2 alkyl derivatives, but rather a halogen derivative, which is a chloral group. You're correct. Okay? So what are 2 other derivatives that we have not talked about yet? Okay, so that's a propyl group. All right. And can we change how we write this? We could also do this, right?
C3H.
Okay. So could we consolidate this structure?
Yeah.
Sure. We could do this, which means the same thing. And could we consolidate the isopropyl derivative?
Yeah.
Certainly could. Could do it like that.
So guys, that long line is isopropyl.
No, it's just, so when you look at here, you don't think anything branching off of that.
So isopropyl and propyl is the same thing?
In a manner of speaking, yes, but the structure's different.
How do you tell the difference?
Okay? So how many methyl groups do we have here? Oh, I did that wrong. Right numbers, but wrong order. There we go. So that must mean this hydrogen we're gonna move that to down here, and then we're gonna move a methyl group to over here, and there is your other one. That is still an isopropyl group. The structure is different.
What if it was just like one big chain down, it'd be propyl?
That would be a propyl, yes.
Are you gonna have isopropyl written out? Like,
Maybe. Could be. Mhm.
so that's an isopropyl group right there?
That is an isopropyl group right there.
Then propyl would just be 3 carbons down, right?
That's correct.
Are those things on the side gonna be on there?
We have discussed them.
Are we naming them or are we drawing?
Could be either one. Naming or drawing them. These over here.
Or are we gonna need to do esters, aldehydes, ketones?
Those, okay, that question is, are we naming esters, aldehydes, ketones? There you're just identifying the organic family. That would be all that you're doing. You're not naming the compound.
And then only 4 questions?
I think that's enough.
There's gonna be like 8 parts to each question.
Probably not. I wouldn't say that. Well, there could be. We have a concerned look on our face. Oh, good.
What about like the phenol and?
Yeah, we discussed those too. Yep. So, before we go any further, can we erase this here? All right. So then, better change colors. What do we have here? Starts with an A. Okay, that is anise. Okay, gives off a very specific fragrance. What about if we would decide to do this? I believe, there we go.
That's vanilla.
Gives off a good fragrance. That's vanilla. Make sure that that's correct. Yep, that is vanilla. All right. And then, or vanillin, whichever one you want to say.
Is that the most complex one? Like that we have to know?
I don't know how people's minds operate, because what might be difficult for one person might not be difficult for the next one. So I really can't answer that. Sorry? No, I'm sorry. Or vanilla. Yes. Okay? Okay. Or if we decide, well, shoot, while we're at it, why don't we just put one more up there? Okay. I'm going to put this up here and OH over there. Then we have this oxygen to C. H3, I believe. Oops, we're missing something here. There we go. Okay, then what do we have here? Oops. Or acetylsalicylic acid, whichever one you want to. Aspirin. Yeah. Yep. Okay. Or in the back row, you had mentioned something about naphthalene, which is true, 2 benzene rings. 3 benzene rings next to one another would be phenanthronine. No, that's not correct. It is anthracene, okay? And then phenanthronine is don't have anthranine running through you. Why is that? It can cause that because it's a carcinogen, yes. Okay. The only other thing I believe that we have not discussed is your organic families and or isomers. So you tell me, maybe you're comfortable with those.
We can probably go with
Okay. So we're going to go ahead and erase these. And
that. Word one again on the bottom right.
aspirin, and this is anise. Okay? So the ones that give off fragrance certainly is vanilla and anise, and then, okay, this is the molecular structure for what we call aspirin, which it has a more complex name, but we really don't need to know that. Okay? I guess maybe we could say there's three things we've only made reference to those. Alcohols could be on there, acids could be on there. Okay, so again, hopefully not too difficult because those are on your handouts that hopefully we're working and making our way through. Okay. We'll shoot for maybe, 3 isomers perhaps of that compound. Okay, the simplest thing you could do from this molecule of pentene would be change it to 2-pentene. Okay? What else could we possibly do?
Move, carbons out.
Okay, so perhaps we're referring to that, so we'll circle that because we're saying we're taking one off, which means you could still have a butene molecule, and then this.
Let's put a methyl group in.
Okay, could put a methyl group there. Okay. Then we could also do the same thing with this here. We'll go ahead and take that one off of the end, and we'll put it in a different color so we can actually see the difference. And we could still have a 2-butene compound.
Wait, don't you? Doesn't it still have to be,
Oops. Doesn't it still have to what?
If you move that methyl group up, there, your longest chain is 4 now.
Right. I agree.
Because that C still has it.
Okay, and then we could just go ahead and do this. Okay, so we're going to eliminate some confusion here. This is your structural formula. What would your molecular formula for this be?
C5H.
Okay, so we said just move your double bond. This has C5H10. Okay, so we know it's got carbon and hydrogen. How many total carbons do we have? Okay, so we've got 2, and 3 is 5, 7, 3 more gives you 10. Then here, probably no surprise, C5, 1, 2, 3, 4, 5. And our hydrogens, we've got 3, 4, 7, 8, 9, 10. Three different structures, all having the same molecular formula. All right.
And then you couldn't move your double bond over to the third carbon because it'd be the same.
It would be the same as if you tried to move this over to here. Okay? That would be No, you could do that. That would be 3-methylbutene. So you could do that. Oh, yes, no worries. Yeah. We're full of hot air in here. Does temperature set that off?
It can, yeah.
It can. Oh, my. It hasn't set it off yet.
No, these are smoke and heat detectors, so if it were
Okay.
to be 135 degrees Fahrenheit up there, it would set it right off.
Because there's lots of hot air floating out
I get what
around.
you're saying. I get it, yeah.
Yep, yep,
No.
yep.
You
Okay.
have a great day, sir.
Well, yes, you as well. Thank you. Okay. Well, it's true.
It's about that 135 up there.
Yeah. In case you're wondering, heat does rise. So, yeah, I mean, there's no disregarding laws of physics. The heat's not coming down unless there's an overabundance of it. And maybe that's true. That just means it's still spreading. It's going up and spreading around like a mushroom cloud. Okay.
What were you saying about you could do that?
Okay, so if we were to move that over,
Oh yeah, that'd be different. Yeah.
that would still be different. So in that case, we could just name that and just say, okay, this is actually 3-methylbutene. Okay, and if you wanted to, you could do that because really it's after the first carbon.
Then your structural formula would be pentene, right? The one that we started out with.
That is pentene. That's correct. All right. So, front row, we're good? Middle row. Back row. Okay, so I understand, hopefully, have confidence in yourselves, just with the idea of, I always like coming to this type of a conclusion, okay? I like to pick on you women all the time. The ball's going up to serve it. Once it gets up there, don't be telling, this is going to be a terrible serve. That doesn't happen, does it? Okay. Okay. So otherwise, just let the ball come back down. Take a deep breath. Gather yourself. And hit it again the next time.
Right in the middle of my backswing.
Okay.
I'm thinking it's gonna be a terrible shot.
If you are not making an offer at the ball, just drop your club. Okay? In other words, if you're doing this is going to be bad, this is going to be bad, just drop it and you can start over.
It's not an effort at the ball.
Then you have a stroke, now you're really mad.
Club comes back down and hits the ball.
Then that's a stroke.
Then you're really mad.
Okay?
What if you're going so back so fast you can't drop it?
Well, then that's just being careless. And even if you are addressing the ball, if you slightly nudge it and it falls off the tee, that does not count. That's right. Okay. Evaluation tomorrow, and next week we'll get into some of the biochemistry. All right, we will catch up to you next time.
They just